Hey Finxters, today we will be discussing how to check for NaN values in Python. So what are NaN values? Now simply put, NaN is a constant value that indicates that the given value is not a number. So that is what it stands for, not a number. You can think of it as a floating point value which cannot be converted into any other type other than float. You should also know that NaN and null are two different things in Python. The null value indicates something that does not exist. However, that is not the case with NaN. NaN indicates any value which cannot be represented as a number. Now, in mathematical terms, these are certain examples which represent NaN values. For example, when you try to find the square root of a negative number, then that will also represent a NaN value. But when you try to perform this operation in your program, it will yield you an error. So before we learn how to find out NaN values, it is essential to understand how to assign NaN values. So that's what we are going to have a look at now. So without further delay, let us dive into our coding screen. So let's say that we have a variable n1 and we want to assign the value nan to this variable. So all you have to do is to use float and pass nan within float. That's it. Now please note that when you pass nan to float, it is not case sensitive. So you can pass it in any of the following ways. So this was the first way to assign nan to a variable. Now we will assign nan to a variable in another way. So let's say that we have another variable n2 and then let's pass NaN in caps. Similarly, these right here also represent NaN values. Now let us go ahead and let's print N1, N2, N3, and N4, and let's find out what's the output. So let's execute this piece of code. And there we go. As you can see that the output represents NaN values for each variable. So this means you can use any of the following ways to assign NaN value to a variable. Well, we now know how we can assign NaN values to a variable. It is now time to dive into our mission critical question and learn how we can detect or check the presence of NaN variable in our code. So there are numerous ways of checking this. We will have a look at every approach one by one. A very simple way to check for NaN values in Python is to use the math module and then use its IsNan method. So let's have a quick understanding of what is the IsNan method. IsNan is a method of the math module that checks for NaN constants in float objects and returns true for every NaN value encountered. If it finds that the value is not NaN, then it returns false. So let's have a look at a very simple example. Let's say that we have two variables, x, which stores some value. Let's say it is a floating point number, which is 25.76. And let's say we have another variable y, which represents a NaN value. Now we are going to use the IsNan method of the math module to check if x and y represent a NaN value or not. If they represent a NaN value, then we will print not a number. Otherwise, we will simply print the value. So all you have to do is to go ahead and use the if statement and check if math dot and then use the isNan method and now pass a variable within it. So this essentially means that we are checking if this value is true, then move inside the if block and then go ahead and print not a number. Else we will print the value itself. Similarly, we are going to do the same thing for our variable y. So let's go ahead and do that. And in this case, instead of passing x within our isNan method, we will pass y. And if it is not a NaN value, then we will simply print y. So the output that we are expecting in this case is it will print 25.76 in the first case, since it does not represent a NaN value. And then this program should print not a number, since y represents a NaN value. So let's go ahead and execute this piece of code and find out if it works. And there we go. It works perfectly fine. And this is how you can use the isNan method to detect the presence of NaN values in your code. So now let's dive into the next approach to check whether a given value is NaN or not. And in this approach, we are simply going to use the not equal to operator to check if the given value is NaN or not. So before we dive into the solution, there is something that you must know. The most unique thing about NaN values is that they are constantly shape shifting. So this means that we cannot compare the NaN value even against itself. Hence, we can use the not equal to operator to check for NaN values. So what this means is that we are going to check if the given variable is equal to itself or not. If it is equal to itself, then that means it does not represent a NaN value. However, if it is not equal to itself, then that means it represents a NaN value. So let's try to understand this with the help of few examples. Let's say that we have a variable x which stores the value 25.55. Now let's say we have an empty list li, and then let's say we have a variable y which represents a NaN value. Now we are going to check if x is equal to itself. So we all know that this expression right here is certainly going to evaluate to true. Similarly, we are going to print the result of this expression wherein we are checking if li equals to li. So that means we are going to check if this empty list is equal to itself. Now, what do you think would be the output in this case? Yes, since this is an empty list, it does not represent a NaN value. Therefore, when you compare the empty list against itself, it will once again evaluate to true. Now, when we go ahead and print the output of this expression wherein we are checking if y equals y, what should be the output? Before explaining this, let us go ahead and let's have a look at the output. Wonderful. In the first case, the output is true. In the second case, the output is true. But wait, in the third case, the output is false. Now, this is because y represents a NaN value and NaN is constantly shape shifting. So that means you cannot even compare to itself. Hence, the output is false. Now, what if you use the not equal to operator and then check if y is not equal to y? What do you think would be the output in this case? Yes, in this case, it is going to yield the output as true. So let's check that. And there we go. Now, as you can see, that we have successfully checked whether y is a NaN value or not. So this is how you can use the not equal to operator to check whether a given variable represents a NaN value or not. Now, another approach to check the presence of NaN values in your code is to use Python Infinity. Now let's have a quick look at what is Python Infinity. So Python Infinity is an undefined value which can either be negative or positive, such that the positive infinity is greater than while negative infinity is lesser than any other value present in your code. Now there are numerous ways of using Python Infinity, and you can have a look at this article to learn about the different ways of dealing with Python Infinity. I will provide the link to this article in the description below. So if you want to learn more about Python Infinity, then you can definitely have a look at this article. Okay, so how do we use Infinity to check whether our program consists of NaN values or not? The idea is to check whether a value lies within the range of negative infinity and infinity. So if your code has numerous values, then they will definitely lie within the range of negative infinity, which represents the least value in a code, and positive infinity, which represents the maximum value that can be present in a code. However, this is not true for NaN values. So this property will not be followed by any value that is NaN. So let's have a look at an example to understand this. Let's say that we have a list li, and let's say within this we have values 10, 100, and then a NaN value. Now let's go ahead and use a for loop to iterate across all the elements of this list. So for I in li, And now all we are going to do is to use the if-else blocks to check if each element or each value within this list, that is 10, 100, and NaN, lie within the range of negative infinity to positive infinity. So we are going to simply check if float negative infinity is less than I, and then if I is less than float positive infinity. If this is true, then we will simply go ahead and print the type of our element I. Otherwise, we will move inside the else block and print not a number. So the first two elements, which are 10 and 100, will be evaluated to true by this expression, and it will print the type of those elements, while the third element represents a NaN value. Hence, it will move inside the else block, and the output in that case will be not a number. So let's go ahead and execute this piece of code and find out if this works or not. And there we go. This program clearly suggests that the first two values are of the type integer, while the last element represents a NaN value, hence it prints not a number. So this is how you can use the range between negative infinity and positive infinity to find out if a given value represents NaN or not. Now we are going to check the presence of a NaN value in our program with the help of the Numpy library. Now the Numpy library has a method known as IsNan, which helps us to detect the presence of NaN objects in our array. So let's go ahead and visualize this with the help of an example. Let's import NumPy as NP. Now NP is nothing but an abbreviation that is being used as an alias for our NumPy library. Now let's say that we have an array by the name ARR, and we are using the array method of the NumPy library to input the following elements within our array, which are 10, 20, and then a NaN value, then 40, and then once again another NaN value. So this is how you can feed in NaN values within your NumPy array using numpy.nan. So this right here represents a NaN value. Now we are going to use a for loop to iterate across all the elements of our array. So for I in ARR, and then we will check if a particular element represents a NaN value or not with the help of the IsNan method. So for that, all we have to do is to use the if statement, if np dot IsNan, and within this method, we are going to pass the value which is represented by I. And if this is true, then we will simply print not a number. Otherwise, we will simply go ahead and print the type of the element within our array. Okay. Now let's execute this piece of code. So the first value, as you can see, represents a floating point number. The second value is once again a floating point number. But now the third value represents not a number because it represents a NaN value. The fourth value is once again a floating point value. And finally, the fifth value once again represents not a number since it is a NaN value. So this is how you can use the IsNan method of the NumPy library to check whether an element in your array object is NaN or not. This is going to be quite handy when you are dealing with data sets wherein you generally have to deal with arrays and matrices. So this is going to be a quite handy method when you are dealing with data sets. Another way to solve our problem is to use the IsNA method of the Pandas library. IsNA is a method of the Pandas library that detects missing values like NaN in an array-like object. It returns true if any NaN value is encountered, otherwise it returns false. So let us have a look at a very simple example to understand how this works. Hence, we first have to go ahead and import the Pandas library. So let's do that. Import Pandas as PD. Now let's say that we have a variable x which stores the value 25.89. So this represents a floating point value. Now let's go ahead and use another variable y which represents a NaN value. Now all we have to do is to go ahead and use the IsNan method from the Pandas library to check whether these values represent NaN values or not. So let's use a print statement, and within it, let's check pd dot IsNa, and now within it, let's pass x. So this should print false because x is not a NaN value, rather it represents a floating point number. Now let's go ahead and use another print statement, and let's check if pd dot IsNa, and then let's pass y within our IsNa method. So this should evaluate to true since y is indeed a NaN value. Hence, let's go ahead and execute this piece of code. And there we go. As you can see that the first output is false since x is not a NaN value, while in the second case the output is true since y is indeed a NaN value. Now I will demonstrate a very simple use case of this with the help of a data frame. So let's say we have a data frame that represents something like this. Let's go ahead and print our data frame. Let's print df and let's see how the data frame looks like. And there we go. As you can see that our data frame has a NaN value present within it at this location. So we are going to check the presence of this NaN value in our data frame with the help of the IsNa method. So all you have to do is to go ahead and use pd.isNa and then pass your data frame to this function. And this will help you to detect the presence of NaN values. Let's also print our data frame first. Now let's use another print statement so that we can visualize the output properly. Now let's go ahead and execute this piece of code. And there we go. As you can see that the output clearly suggests that we have a single NaN value present in this data frame, which is at this location. Otherwise, for every other element in this data frame, we have the output as false since they do not represent a NaN value. Only this value is NaN, hence the output in this case is true. So that's how you can use the IsNa method from the Pandas library to detect the presence of a NaN value in your data frame. I hope this helped you. If you have any doubts, please mention them in the comments below and I'll try my level best to answer all your queries. Thank you.